Hey there, Patriots. It's time for us to do our Unit 8 test review. Test is going to be next class period, so 2 days from now, so I believe on February 10th. And it's going to be a quizzes test just like we've done before. So if you're able to be successful in this review, then you can be successful on the test as a whole, as always. And remember, the best way to use this is to actually try it on your own first and then come and find a problem that you want help on, as opposed to just watching the entire thing and copying what I write down. But anyway, here we go. Let's jump on to number 1. Write the square root function when the following transformations are applied to the parent function. So remember, this all stems from what we did back in like Unit 3 or 4, and where we had the equation y equals a times the square root of x minus h plus k, where h is the horizontal shift, k is the vertical shift, and a handles both our reflection as well as our stretch and shrink. So I'm going to go ahead and write in my square root of x. Okay, shifted 2 units right. That is going to be a horizontal shift, but remember the inside lies. So right is a positive direction, but we've got to go the opposite sign. So that's -2. That's that one there. Then 7 units up is k, our vertical shift. And that uses the right direction, so up 7 is +7. Then we've got the vertical shrink of 1/2. That comes in on the a value, so we put a 1/2 here. And then reflect it across the x-axis. That is where we're going to add in a negative sign on the a. So there we go, y equals -1/2 square root of x minus 2 plus 7. Okay, over to number 2, exact same idea, but with a cubed root function this time. Y equals a times the cubed root of x minus h plus k. So let's go in and make sure I'm using my same colors here for consistency. Okay, shifted 5 units to the left. That's an h value. Oh, I'm going to go ahead and plug in y equals cubed root of x. Okay. So inside lies, so left is a negative direction, so we're going to put the opposite sign, so +5. Then 3 units up is our k value, and it goes the right direction. Up is positive, so +3. And then a vertical stretch of 2 is the a value, so I put a 2 there. And there is no reflection, so we are good to go. It is 2 times the cubed root of x plus 5 plus 3. Okay, moving on to number 3. We're going to write our equation. And the first thing we're going to do is figure out what our parent function is. Now, this is going to be a square root of x because of the fact that it starts at a point and is on the top half of a parabola. So I'm going to go ahead and set in this. And we're going to see what our stretches and shifts and everything are. So let's start with our horizontal shift. I went left by 3, and that's a inside. I'm sorry, I should have done that in blue, whatever. Horizontal shifts are inside, and so since I went to the left 3, I need to actually add 3, because that is a inside lies. Also, we're going up 1 on my vertical shift, so that's +1 on the outside. It has not been reflected because it's going up, so I don't have to worry about a negative sign. But we're also going to look at, for the stretch, that point right there. Remember, the relative point should be 1, 1 relative to the vertex. And since it is 1, 1, then we don't have to worry about any sort of stretch or shrink. Now, that comes from the fact that our original table was -2, -1, 0. Oh, I'm sorry, I should be doing square root, not squared. 0, 1, 4, and 9. So the point 0, 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And so this thing right here, these 2 points, can tell us what the stretch is. So basically, if this had been any number besides 1, let's say it had been a 4 right there, the point 1, 4, then I would know that my a value equals 4. So whatever this relative point is, that vertical piece is going to be your a value. Okay, let's jump over here now to number 4. We've got a cubed root. So we've got y equals cubed root of x. And let's see if we can figure out where exactly the center point is. Let's see. Oh, look, it's actually been marked for us. Our center point is right here at -2, -1, which tells us our x and our horizontal and vertical shifts. Our horizontal shift is going left by 2, so we're going to make that a +2. The vertical shift is a down 1, so we make that -1. And now again, let's think about our XY chart. I'm not going to do the full thing out, but if I did 0, 1, sorry, it's cubed root. So 0, 1, and 8. Cubed root of 0 is 0. Cubed of 1 is 1. Cubed root of 8 is 2. And so again, my normal parent function, the point is 1, 1. If I look at this relative position, it's 1, 1, 2, 3, which means that I had to multiply this times 3. So my A value is 3. And it is going the correct direction, so there's no negative. So there we go. Y equals 3 times the cubed root of x plus 2 minus 1. All right, moving on to number 5. Graph the following functions. So we've got our square root, and let's go ahead and bring our shifts in. -3 means it's going to go right by 2, plus 2, I'm sorry, right by 3. Plus 2 means it's going up by 2. So I'm going to go over to the point 1, 2, 3, 1, 2. And there is no A value, so it's going to have the point 1, 1, and then 2 square root, so 4, 2, 1, 2, 3, 4, up 2. There we go. There's the top half of my parabola. Now for domain and range, the domain is going to start at 3 and go on to infinity. The range is going to start at 2 and go on to infinity. Remember, for domain and range, we're looking at left and right, and then top and bottom. All right, number 6. We're going to have a shift of 3, so only go up 3. Don't go left or right anywhere. Got the y-intercept at 0, 3. And now we've got our, oh wait, actually, no. That's inside, so that should be a horizontal shift. So that's left by 3. So we're going to do the x-intercept at -3. Now, the A value of -2, first off, that's going to be a reflection, so it's going to be going down. And the 2 value means that we're going to, on our parent function, we had our table, we had x, y, 0, 1, and 4. Square root of 0 is 0, and then 1, and square root of 4 is 2. So we're going to be basically multiplying all of our y values by -2. That's still 0. 1 times -2 is -2. 2 times -2 is -4. So from this point, we're going to go down to right 1, down 2, right 1, 2, 3, 4, down 1, 2, 3, 4, and there is my parabola. For my domain, looks like I'm going to start at -3 and go on to infinity. For the range, since it's pointing down, my lower boundary is -infinity. Make sure you have that negative sign inside of there. And my top value is 0. The highest y value is 0. Number 7. Now we're dealing with cubed roots. So on this one, I'm going to go ahead and make my table just so I can have it whenever I need it. -2, well, cubed root, actually, I'm sorry, -8. -1, 0, 1, and 8. -2, -1, 0, 1, and 2. All right, let's look at our shifts here. This one on the inside, it means we're going to go right by 3 and then up by 4. So right 1, 2, 3, up 4. From there, I'm going to plot all of my points. So I've got the point, oh, there's no A value, so I don't have to shift any or do any stretching or shrinking. So I've got the point 1, 1, and then I'm not going to be able to get to 8, 2. But here I've got -1, -1, -2, -1, 2, 3, 4, 5, 6, 7, 8. And then for cubed root, it is all real numbers for everything. Okay, for number 8, we're going to go on, and I've got my -4, which means that is a shift down by 4, no horizontal shift. So the center of my my cube root is going to be at 0, -4. Now I do need to multiply all of my values by 2, so this will be a -4. -1 times 2 is -2, 0, 2, and 4. Let me go to the point 1. Oh, what am I doing? Yeah. 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. -1, -2. And then -8, -4. And then my domain is all reals for all cube roots. Okay, number 9. Now we're going to be doing our cubes. So to make the table here, I'm going to do my x and y. On this one, I can do -2, -1, 0, 1, and 2. Cube those, I get -8, -1, 0, 1, and +8. Okay, so for my shift here, -2 is right by 2. So my center goes out to 2, 0. And I've got the negative sign here, so I've got to negate all of these. So I'm going to go over to 1, -1. And then 1, 2, -8. And then 1, 1. And then 2, +8. And my domain and range, again, are all real numbers for both cubics and cubes. Over to number 10. This +4 means I go left by 4. The -1 means down by 1. So -4, -1. And there is no stretching or shrinking, no reflections. So I do the point 1, 1, 2, 8. And then -1, -1, and then -2, -8. And then, of course, all real numbers for domain and range. Okay, our next section is going to jump back to the first lesson of the unit, and we've got quite a few of those. Where the big thing here is we want to take our, for the coefficients, we want to take our prime factorization, and we're splitting it up into groups of whatever number is in the index. In this case, on number 11, it is a 3. So let's go ahead and start breaking this up. 343, and I am not good with mental math these days, so I'm going to jump in and use my calculator on this. So I know for sure a 2 does not go in, so let's do 343 divided by 3 does not work. I don't know a 5 does not go in, but we're just testing primes as we go up. Let's do 343 divided by 7. There we go. There's 7, and then that goes in 49 times, and then 7 and 7. So I've got a group of 3 7s. So that is just, the answer is just going to be 7. But now this negative sign, remember with odd roots, the negative sign just comes out as well. So we've got -7. For number 12, let's do the 192 first. I know for sure a 2 will go in 96 times. I've got another 2 48 times. I know I've got another 2 24 times. I've got another 2 12 times. I've got another 2 6 times. I've got another 2 3 times. I've got prime at the bottom. Now I am done. Wow. Okay, let's see what we got here for our coefficients. There's a group of 3. There's a group of 3, and that 3 is going to stay on the inside. So when we're done with all this, we're going to have a group of 2 comes out. Or the 2's come out because that's the basis of these groups. But there are 2 of them, so I put an exponent of 2. And now let's look at our our exponents. But for the exponents, we're going to divide the exponent by the index, and then the whole number part goes on the outside. The remainder stays on the inside. Well, 9 divided by 3 is 3, so I've got an x cubed on the outside. I've also, 6 divided by 3 is 2, so I've got a y squared on the outside. No remainders on those, so nothing remains on the inside. However, this 1, 3 down here does. So my final answer, once I've simplified it out, would be 4x cubed y squared square root of 3. All right, number 20, we're doing square root. Or number 13 with a 20 in it. Okay, a 2 will go in 10 times. Then a 2 will go in 5 times. And now 5 is prime, so I'm done with that. This is a square root, so remember there is a hidden 2 right here. So whenever I write my answer, I'm going to have one group of 2's on the outside, and I'm going to have a 5 left on the inside. Now the 12 divided by 2 is 6 with no remainder, so we're going to have an x to the 6th on the outside. 2x to the 6th square root of 5. Okay, number 5 is just a set of numbers. So we've got a 5th root there. Stop that. Okay, 31, 25. 2 does not go into it because it's not even. Let's try 3 just to see. 3 does not, so we're going to start going to 5s. 31, 25 divided by 5 is 625. Now I know 5 will go into that one again, 125 times. Let's try the 5 again. I know for sure it does. It'll be 25, and then 25 is 5 times 5. Now because the index is 5, I'm doing groups of 5. 1, 2, 3, 4, 5. I've got 5 of them, and so the answer is just going to be 5. Yeah, that's a lot of 5s. Okay, number 15, cubed root of 40x to the 17th. Let's do the 40 first. 2 will go in 20 times. 2 will go in 10 times. And then 2 will go in 5 times. 5 is prime, so I'm done with it. So we do circle groups of 3. So I've got a 2 on the outside, and then a 5 remains on the inside. Now our 17, I'm actually going to do this one out because it has a remainder to it. So 17 divided by 3, well, 3 will divide into 17 5 times. Subtract out that 15, so it's 5 remainder 2. So I've got x to the 5th on the outside, and then x squared on the inside. Remember, the remainder stays inside. Okay, number 16. Let's start off with our coefficients. 135. It's not even. I don't think 3 will go in. Oh, it does. 3 goes in 45 times. Then 3 will go in 15 times. Then 3 will go in 5 times. 3 of an index of 3 means I've got groups of 3. So for my square root here, I'm going to do a 3 on the outside and a 5 left inside. Now, whenever I divide my exponents by the index, 7 divided by 3, let me write it this way. 7 divided by 3 is 2 remainder 1. And then 9 divided by 3 is 3 remainder 0. So for the A's, I've got an A with a 2 on the outside and 1a on the inside. For the b's, I've got a 3 on the outside and nothing on the inside. So 3a squared b cubed times the square root of 5a. Okay, moving on to number 17. Now on this one, because this whole thing is in parentheses, I'm going to start off by simplifying the exponents. 6 divided by 3 is 2 remainder 0. So that cubed root symbol is going to be completely wiped away. I'm going to have 2x plus 1 squared, and that is all. I could expand it out, but I'm not going to. It just simplifies down to 2x plus 1 squared. However, keep in mind on the test, you have multiple choice. So if you had to expand it out, like if that answer wasn't there, go ahead and expand it just to see what you get. If you needed to expand it out, we do box method, 2x plus 1, 2x plus 1. Then we multiply through. 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times 1 is 2x. 1 times 1 is 1. I've got my like terms here. So that would simplify down to 4x squared plus 4x plus 1. Either one of those is correct. Again, multiple choice. Just take the one that is there. Okay, number 18. We're going to do the exact same thing. 12 divided by 4 is 3 remainder 0. And so we're going to have x minus 1 cubed. Okay, that screen just glitched there for a second because I was actually went through and checked the test just to double sure, or just to be sure. The test, it leaves answers in this form, so you don't have to worry about doing this. So don't worry about expanding it out. There's only one question that does that, so you're only going to have to do it on one. Number 19. Let's do our coefficients first. So we've got 275. 2 definitely does not go in. 275 divided by 3 does not. So 5 definitely will. So 5 will go in 55 times, and then 5 will go in 11 times. 11 is prime. And so I'm going to go ahead and put my square root symbol here. No index means an index of 2, so I've got groups of 2. So I've got a 5 on the outside and 11 on the inside. Now that negative sign is also going to go along for the ride because it doesn't, any coefficients at the beginning stay at the beginning. Now let's do x squared. Well, square root of x squared, 2 divided by 2 is 1. So we're going to get an x on the outside. And then y does not have enough to come outside. So we got negative 5x square root of 11y. Okay, next section, finding inverses. Now remember, our basic form for finding inverses is to switch the x and the y and then solve for y. So we're going to subtract 4 on both sides. That's going to give me x minus 4 is equal to 2y. Now let's divide everything through by 2. Which is going to give me y equals x minus 4 over 2. And now let's go ahead and distribute out that divided by 2. So we're going to get this as y equals negative x over 2, and then negative 4 divided by 2 is minus 2. Now, keep in mind that these two are two different ways of writing the exact same thing. Oh, that should not have been a negative. Sorry, that should have been an x over 2. And again, it's just whichever one is going to be on the answer choices. But remember, you can distribute that 2 if you need to. Okay, number 21. We're going to rewrite this by swapping the x and the y's. So I've got x and y equals 6/5. X equals 6/5 y. Now, the way I get rid of a 6/5 is by multiplying both sides by 5/6. And the reason we do that is because the 6's cancel, the 5's cancel, leaving me with y equals 5 over 6x. But we want to write this in inverse notation. So we get f inverse of x is equal to 5 over 6x. Okay, now on the number 22, x equals y minus 2 cubed, swapping the x and the y. And now we're going to do all the inverse functions. So cubed root is going to cancel out the cubed. So now we're left with cubed root of x is equal to y minus 2. And so we've got to add 2 to both sides. Gives me y equals the cubed root of x plus 2. And make sure that plus 2 is outside of the parentheses. And instead of y, we're going to be writing f inverse of x. Now remember, we could have done that using the intuitive inversing method that I showed you all the other day, where I say that the inverse of cubed is cubed root. The inverse of a minus 2 is a plus 2, and also the inverse of inside the parentheses is outside the parentheses, which is why that plus 2 is outside. I'm actually going to use that on this one. Go straight to the inverse. G inverse of x is equal to, the inverse of a squared is square root. Now the inverse of a plus 2 outside is a minus 8 inside. And the inverse of a plus 3 inside is a minus 3 outside. So G inverse of x is square root of x minus 8 minus 3. Okay, number 24. We're going to do this the traditional way. X equals 3 y squared minus 1. Okay, the first thing I'm going to do is add 1 to both sides. So I've got x plus 1 equals 3y squared. Now we're going to divide both sides by 3. So that gives me x plus 1 over 3 equals y squared. Then we take the square root of both sides. So that gives me y equals the square root of x plus 1 over 3. And again, for answer choices, realize that again, that 1/3 could be distributed out. So it could be x over 3 plus 1/3. Or you even write that as 1/3 x plus 1/3. There's also different ways of writing that. So again, multiple choice, pick the one that fits best. All right, number 25. Let's do this one the intuitive way. H inverse of x equals, now remember there's a set of parentheses right here. There's a plus 0 inside, so we don't have to write it. Inverse of cubed is cubed root. And then the inverse of minus 7 outside is plus 7 inside. Okay, doing good. We're almost 30 minutes in, and we are getting closer to being done. Okay, Mr. Tarleton graphed 2 equations of the same grid. Are they inverses? Remember, to check inverses, what we're going to do is take our straight edge and draw the line y equals x. So it goes to the origin and has a slope of 1. And then we're going to say, is this a reflection over that line? Well, definitely not. It would be a reflection if we went the other direction, but that's not what we're doing. We're going to y equals x. So no, because it is not a reflection over y equals x. Okay, number 27. Again, we're going to draw the line y equals x. And we're going to say, is that a reflection? And yes, this one is a reflection because they are reflections over y equals x. Okay, 28, we're going to do this by graphing. So let's take the square, x plus 5. So we got plus 5, slope of 1. And now we've got minus 5 with a slope of 1. And now we're going to draw the line y equals x. And are those two blues a reflection over the purple? And the answer there is yes, they are. All right, number 29. Cubed root of x minus 3. So we're going to drop a vertical shift of -3. Rise 1, run 2, rise up to 8. Boom. There we go. Now, cubed root of x plus 3. Well, I'm going to go over to plus 3. And it's up 1, 1. And then down 2 over 1, 2, 3, 4, 5, 6, 7, 8. And so we're going this way. Wait, I made a mistake there. That is a shift of left 3, not right 3. So left 3, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. I should have done that. And there we go. Is that a reflection? Yes, that is a reflection. Well, the way I caught myself there is honestly, I could look at this and using my intuitive inversing method, I could see that those should be inverses. And so that told me I did my graphing wrong somehow. So all those disciplines kind of jump together. Okay, determine if they are inverses by graphing. Let's do the vertex. So both of those have the y-intercept of 4. F of x has a rise or a slope of 2/3, so rise 2, run 3, 2, 1, 2, 3. You know what? I'm going to go ahead and graph the line here on both of these. That way I don't have to reposition my ruler again once I change it. Okay, now 3/2 x plus 2, so plus 4, so same y-intercept. Rise 3, run 2, 1, 2, 3, 2. Yeah, that one is definitely not a reflection over the line y equals x. All right, number 31. I hope at this point you can look at it and look at those two and tell it's not going to be inverses. In particular because my 2's are on the outside of everything. But anyway, we'll graph it just to be sure. So that is up 2 and right 4. 1, 2, 1, 2, 3, 4. And that is a cubic, so over 1, up 1, and then over 2, down 1, 2, 3, 4, 5, 6, 7, 8. And then for this one, I'm going to go up 2 and right 4 again. 1, 1, 1, 1, but now I'm going to go down 2, 1, 2, 3, 4, 5, 6, 7, 8. And yes, they're not reflections over that line, so it is no. Okay, 32 through 35. This is our last section. We're going to do this by composing our functions. We're going to do it by finding f of g of x and g of f of x. And remember, if any one works, the answer is no. I'm sorry, if any one fails, the answer is no. It's got to work for both of them. So let's start off with f of g of x. So we're going to start off with f. F is going to be 1/2 x plus 5. And inside of f, we're going to place g. So 2x minus 5. Let's distribute out the 1/2. And so I will now have 1/2 times 2x is x. 1/2 times -5 is -2.5 plus 5, which comes out to x plus 2.5. That is going to not work, so the answer is no. I was looking for just an x. Okay, let's do f of g of x. So start with f. Let me make this one pretty wide. And where the x was, I'm going to set a set of parentheses. And then inside of that, I'm going to place into it g. So I've got square root of x plus 3. Now let's collapse these down. Nothing to do inside the inner parentheses, but those two will cancel out, leaving me with the square root of x squared. And the square root of x squared is just x. So that one did work out like I wanted it to. Now let's do g of f of x. Start with g, so square root of x plus 3. And where the x was, we're going to replace that with f. We're going to replace that with x minus 3 squared. So now our square root and our squared cancel, and that leaves me with x minus 3 plus 3, and then those two 3's will collapse down to just x. So that one worked, so our answer is yes. All right, number 34, f of g of x. So f is 4x plus 8. We're going to place in there 1/4 x minus 2. Distribute the 4, and I've got 4 times 1/4 is 1x. 4 times negative 2 is negative 8 plus 8, which comes out to just x. So that worked. Now let's do g of f of x. So start off with g, 1/4 times x minus 2. Inside of the parentheses, I'm placing a 4x plus 8. Let's distribute the 1/4. 1/4 times 4x is x. 1/4 times 8 is 2. And then those 2's will collapse, and now I've got an x. So they both equals x, so the answer is yes. And 35, let's do f of g of x. So f is the cubed root of x minus 2. Where the x was, we're going to place in g, so that is going to be x minus 2 cubed. Now my cubed root and my cubed will cancel, leaving me with x minus 2, and those two 2's combine together to make a minus 4. So that one fails, so my answer is no. So that's all I got for you today. Good luck on the test. There's going to be 20 questions, multiple choice on quizzes. Look for that starting on the 10th. It'll be open for a couple days. Let me know if you have any questions. I'm available every single morning for tutorials from 8 to about 8:35 on Google Meet. The code is EVHS Mr. Love. That's EVEHS MRLOVE.